Okay, now that everybody else has had to have the cool one-slide graphics about the internet, I'll make mine real quick because other people did a better job. 444%, ooh, we got the numbers right. Same of it, both of us. From 2009, 28% penetration in the market for the world. Currently about that amount of addresses, maximum amount of addresses here. 210 approximately. It's interesting that we have as many websites today as we had users 10 years ago. Found that kind of interesting. Right now, the average user has 2 IP-enabled devices on them. Okay, how many of you have a laptop? All of you over here, and also a phone that has an IP address. Gizmo's actually expecting that the average user, okay, we're above average, we know that, will have approximately 10 devices per user. I have over 30 devices at home, so I'm not sure where I'm multiple standard deviations away from what normal is, I guess. We need more addresses to grow the internet. Interesting quote. I had dinner with Jill Alexander, and he was he pretty much told me that there's approximately 7 billion devices out there with IP stacks today. So if we have 3 approximately billion devices that have internet addresses, and we have 7 billion that have IP stacks, there's a real big demand for potential connectivity once IPv6 is rolled out. Okay, so IPv6 exhaustion, something I get all the time. And by the way, if you're doing security, this is a good discussion for your security guys. Usually I get IPv6 address exhaustion, no way, it's just a marketing thing. Here's, we talked about this a little bit earlier. Here's some of the issues we're living with because of NAT. Sorry, NAT had to happen, but here's some of the issues we're dealing with. Number 1, loss of end-to-end trust. We've seen DNS spoofing attacks that allow basically internal traffic to be redirected external. Dan Kaminsky demonstrated those attacks 2 years ago. We saw certificate servers being attacked. Again, man-in-the-middle attacks because NAT, because essentially we have devices in between that change the actual connections. Our cost of deploying, because of deploying NAT, is a lot higher. Our development costs are higher. We also had a loss of visibility. If somebody in your organization is attacking the internet, or somebody out on the internet is attacking, the lights are going down. I do need my laser. If somebody's actually attacking your network, you don't know if that's the unique IP address or a NAT. In some cases, maybe it's a NAT behind a NAT behind a NAT. Why does this impact you? Does anybody use blacklists for email? Does anybody use blacklists and bogon lists? Anti-spam lists? This could be a real problem with some of the other techniques of, that we're expecting. And by the way, this has caused organizations to be blocked out because somebody within their organization or connected to their organization actually forced to be blacklisted. So that's been a problem. We also saw a lot of man-in-the-middle attacks for a while. We also have an issue of ports really don't mean anything anymore. Some of us are old enough. Some of us have gray beards or no hair. Some of us are old enough to remember when certain ports meant certain things, which meant instead of parsing for an application to parse through a protocol with a very small regular expression, now we have regular expressions that may be 10K, 15K in size just to parse a web browsing application to see if it has a particular protocol built into it. So it's very difficult. It's very hard on the systems at this point. Future, as we add more NAT, yes. We add more complexity and more expense. Security is more expensive because those devices we buy for firewalls and such are becoming larger. And we talked about the default free zone routing table becoming too large. It would not be real good if, say, I was on AT&T and you were in Verizon and we had a collapse of the routing table for a period of time where I couldn't, access you, email you, whatever. Those are potential problems with this exhaustion. NAT translation evil. Repeat after me. NAT translation is evil. Yes. Okay. So originally designed by RFC 1631. It was a great idea at the time, so not a big deal. It was meant for dealing with the scalability. And until this new protocol was available, we now call it IPv6. Unfortunately, it's not security or privacy. I have a lot of security certifications. A lot of those security certifications actually tell you NAT is about security. It's not about this. So we have a whole generation of IPv4 people that are brainwashed that this has to do with security. Well, it really doesn't. We're going to talk about why it isn't. It really destroys end-to-end connectivity, the peer-to-peer stuff. We had to make special provisions for IPsec because we had to go through NATs. We also had lots of applications. This is a great link, by the way, to show applications. And the more changes we have to make to a protocol, the more complex a protocol, the less secure it's going to be. Okay, it also adds cost, time, complexity. Has anybody tried to connect multiple NATs together so you can communicate? Where I basically have, company A and organization B, and we have NATs, and they all are using the same 10 address, and we have to sit and map that. How do you test that? How do you validate the ports are correct each way? You put it in a big spreadsheet. It may take you a day or two. And then you have to go through the testing to make sure that you don't have that the addresses, assignments, and the right ports, the right connections set up. Very expensive. So NAT's not needed, but stateful firewalls are. Because that's really the thing that allows us to maintain state, to see the packet going through, parse the packet, ensure it's proper, keep the connection open, and allow connections to come back. Okay, NAT is evil. So do you know of any other protocol that has techniques to bypass it? Is there any protocols you guys know? Look, NAT has all of these. They're very special. Okay, and it maybe has ways of modifying the router. That could be handy. By the way, we saw some malware doing this a while back, modifying routers to make connections outbound. And for a good protocol, you wouldn't have things that would actually ignore using that protocol, would you? Well, actually, we do with NAT. And then, a lot of people say, hey, it hides my internal address, right? You hear that all the time. Well, if I put a little Flash application that you're watching on your system, that Flash application will send me back an IP address of your internal system. Sending a malformed email through your email server will allow me to map your internal system. Okay, this is me putting on my black hat. But these are real easy things to do. Having you create a PDF, sending you a PDF, a Flash, authentication, web cookies, this actually allows trackability. So for a protocol that was to extend the internet long enough until IPv6 was available, big win. For a protocol that actually provides security, not so much. IPv6 fail. So IPv4 fail. IPv6 is a better solution than that. Okay, everybody's seen this, but let's talk about the implication of these three items. First, we have the ICMPv6. Ooh, can I do this over my shoulder? Yes. Right there. The address resolution. Has anybody had to ever implement taps on their networks? Those are layer 2 sniffing infrastructure. And we do that because we need to gain access to ARP. We need to gain access to our layer 2 transactions to see what's going on the network from an attack standpoint, especially if you're using IDSs or what. That way we can find new devices that are connecting to a network, whatever. Because IPv6, we're using neighbor discovery, which is a multicast address. That's a layer 3 protocol. That allows us to kind of avoid implementing taps in a lot of situations, especially for IDSs. So this can become real valuable and drop your cost of implementing, IDSs across an infrastructure. One of the fails is IPsec mandatory. As multiple speakers discussed in the last 2 days, IPsec isn't fully implemented in IPv6, unfortunately, and a lot of product vendors have kind of forgotten that it even exists, which is kind of a problem. A win, though, is fragmentation. Because a host is doing the fragmentation and not the router, it allows us from an IDS, IPS standpoint to avoid a lot of the overlapping protocol problems. I have a set of tools that allows me to take a set of packets, fragment them, and actually overlay the port number with another port number and a whole particular attack strategy, which allows me to slip through IDSs. With the capability of the host doing fragmentation, and because the fragmentation are now end-to-end, we can mitigate a lot of IDS problems that we're currently having. And by the way, that code is so complex in IDSs today that they have led IDSs to vulnerabilities. Nothing more fun than watching the IDS die. Yes, I'm using animation, isn't it scary? Okay, another thing. Our devices, they have link local addresses. They have potentially global ULAs and privacy addresses. We have loopback addresses. We have all nodes multicast addresses. We have a solicited node multicasts. And then we have additional application-based multicasts. Why is this a problem? Typical systems have 5 or more addresses assigned to their system that are network exposed. Why is this a problem? I'm going to bring back Jeremy Duncan's comment. The current scanners have no way of finding these addresses. Therefore, the only way for you to perform an assessment against each system is to log onto each system, gather the addresses, put it into a text file because none of the systems allow you to cut and paste those addresses, and then you pass that to Nmap, Nessus, or a dozen other applications. Retina still fails on that. But even Retina, as an example, doesn't know how to deal with multicast or anycast addresses. Won't actually see that a process is bound to a port. So this is a real problem with a lot of scanning tools. Also, a lot of IDSs are blinded to different classes of addresses. They don't know how to handle it. At one point, a well-known, they call themselves a TiVo of IDSs. What they were doing is they were switching bits around, but doing it in such a fashion that you couldn't actually look for any attacks against your network. And all devices, whether they be global, local, ULA, multicast, only showed the last 32 bits of the 128 bits. Kind of a problem, right? So also a lot of tools, a lot of IDSs, a lot of products don't know how to create context around one device. If I have one computer and it has 5 addresses, how do I wrap that around and say these are the 5 addresses for this particular device? Right now, there's not a lot of products out there that perform that capability. Why is this a problem? Well, if you're performing, say, a Sarbanes-Oxley assessment, does anybody have Sarbanes-Oxley's or HIPAA or anything else in your environment, NIST, whatever? The auditors only know to look for one unicast address. Nothing else. Ask them, what do you do for IPv6? Wait until they tell you to use Retina. Ah, yes. So there's a problem. Let's go back to the NAT discussion. NAT was a way of hiding the internal infrastructure. What systems are on the internal infrastructure? Well, from a discovery standpoint, we have the capability of using ULAs. ULAs are large address spaces, and we'll show you how big the address spaces are in a minute. We also have the capability of doing link local addresses, inbound connected only addresses, and outbound connected. I actually have my browser set up to do privacy addresses and reset every 10 minutes Okay, maybe that's a little bit extreme, but it does make it real nice when I'm going back to a system, doing testing, especially if I'm sniffing the inbound traffic to see if an attacker is actually following me back to my address, which sometimes they do. This allows us to provide a lot of granularity on security controls around both our inbound and outbound addresses. This is something that hasn't been thought about a lot, but the capability of saying, I have a link local address that has to have a specific security policy, my ULA can have a specific policy, and my global outbound address can have a specific policy, and if this device allows inbound connections, I can apply a policy there. Again, a lot more granularity than we've had before. And this is good. So, oh yes, each home user gets lots of addresses. I don't think I'll be able to do this in my lifetime. I've tried to figure out how I can put this amount of devices on my network. It's not going to work. So, protocol precedence. This becomes important for when you're implementing a system and also from a security perspective. First we try IPv6, then we go through the tunnel paths depending on which operating system. 64, ISOTAP, Teredo, ooh, I love this new Microsoft one, IPv6 over HTTPS over IPv4. It's so brilliant. I want to see your IDSs find that. It's pretty neat. Also, we have the other tunnels, gogoNET, HE, and 6SX. And then we default back to IPv4. Well, I attend and participate and speak at a lot of security conferences, hacker conferences maybe. And for the last 3 years, one of the fun things I've done is they've told me that all their networks are IPv4 only. Well, I've just crafted a simple packet that set them the default router in IPv6. About 60% of the devices will then respond to try to default connect back to me. So then I said, let's port scan them. Let's not attack those systems. Let's just port scan those systems on this segment. Half of those systems had no firewalls on them. So what we have is people that are running around that have an IPv6 stack on it, that don't know that they have an IPv6 stack, and haven't applied firewall rules, simple firewall rules. Okay. We also obtain our routable addresses. First we go for a static table, our host file. We then go with our stateless auto configuration, and we do our DHCP. I want to mention this. We started seeing malware create host files for IPv6 addresses just recently. So it's something to be aware of if you are in a non-IPv6 environment and you start seeing IPv6 addresses in a host file, there's a good chance some malware is out looking for things. Okay. Also another issue. Okay, I run multiple IPv6 networks at home. Okay, like I said, I have lots of devices, and I also don't juggle real well. So I have a firewall. And I have this really cool new, this really cool new HP printer. It supports IPv6. Well, I don't know, but I don't want you guys to actually print to this printer. Okay, I appreciate this, and ask me over a beer and I'll tell you stories about that. Who is responsible to issue that address? Where's the controls? The printer has no firewall rules to say, okay, I'm going to allow a local scope address. I'm going to allow ULA, but I'm not going to allow this particular device to have a global address. That's neither on the firewall or on the device itself. So I'm finding these kind of very strange problems, not only for home users, but also enterprises, that somebody hasn't kind of thought through some of these issues. So, you know, you could end up with your plotter or printer out on the internet because policies don't exist and people haven't thought through this process. And yes, it is really fun to print really large plotters. Okay? Now I'm going to talk about it from a hacker, from a penetration tester. We talk about things called target space. What are the devices that an attacker is going to target on your network? Well, right now we have all these operating systems that support IPv6. The actual size of the target space of that 7 billion devices with IP stacks on them, we have between 500 and 900 million devices as of October that potentially have dual stack or IPv6 on it. That's a big attack space. We also, I'm expecting frantic migration based on, by the way, this presentation and other things next year, first quarter, migrating to IPv6. If we take any history, any idea of history on people implementing web servers and such, we saw a lot of people implement web servers with no security, no firewalls, no IDSs, no anything. So I expect that a lot of people are going to try to implement and open up security problems. We also have multiple layers actually impacted. So let's talk about the surface area from a different perspective. So originally we had lots of other protocols and then we got down to one to rule them all, IPv6 or IPv4 native. Then we had tunnels because we had to have encapsulation so we could traverse different networks. We had to have encryption because that's good. Then we added IPv6, so now we've added additional attack spaces. Then we added NatPT, yes. Then we added V6 Lite, Nat6, and carrier-grade NATs. Each of these are potential target spaces for an attacker to go after, be it man-in-the-middle attack, denial of service attack. There's lots of places that people can attack these things. I've been doing lots of research on these, and these can be very problematic if you look at it from an attacker standpoint. Okay, let's flip those sideways. Here's the layers of targeting. We kind of expect that people are going to implement at network layer, something wrong in the IPv6 stack. I mean, it's pretty complex. But we've also seen L2, L3 mismatch, MTU mismatch problems in some of the older devices. Some of those devices are still out there. We've also seen improper implementation of the shift between layer 3 and 4. We've also seen lots of application errors, mostly user interface. Again, the inability to add a user interface, do multicast, do anycasts. Chopped up addresses, that's my favorite. There's a well-known product that only sees the first 32 bits of 128 bits. Kind of a problem. Lots of bad libraries. Fortunately, we've seen Perl, Python, Ruby, things actually being upgraded within the last 6 months. But some of the libraries are pretty bad, and some specific implementations are really bad. Error handling is very poor for V6. It can actually cause some of the applications to crash, which is a problem. And also embedded addresses, which we talked about earlier. So people always say, hey, Joe, I've never heard of an IPv6 attack. Well, actually, there's been a few. Actually, the first one that was documented was in 2002. During the HoneyNet project, Lance said, hey, my system was just attacked. I think it's IPv6 on my Solaris attack. And it was a 6-to-4 tunnel. Can anybody confirm that they've also seen this? Well, people started posting that they were attacked all the way back to 2001 after reviewing their logs and other things, that they also were attacked. They didn't know what the protocol was. We saw Marty actually include and then remove IPv6 capability back in 2002. Why, I don't know why. We saw a worm that once it infected a specific system under IPv4, it tried to make an IRC connection back via IPv6 first, and then back to IPv4. We saw a Trojan trying exactly the same thing. 2005 was the using Teredo as a covert channel. That was something that I started when I presented to the FBI, when I realized that Teredo is a really cool protocol because it bypasses NAT. But my favorite part about it is there's no firewall on it. So once you can identify the connected public IPv6 address, you can port scan that thing, and you can't apply a firewall to it. Kind of a problem. Then we saw the Klein attack, and you can ask our Cisco guys if you want any comments about that. We saw THC tools, which are very good, by the way, if you want to do testing, except that he's coded some hidden little surprises in there, so be careful. They're good for doing testing. RP Murphy talked about covert channels. We saw a rootkit that tried to talk IPv6. Hagelin actually in 2007 mentioned some of the flaws in Teredo, which made it easy to identify where the endpoint was. I gave a presentation at HOPE in 2008 after 2 years giving a carrier and their cell phone infrastructure time to try to fix it. What they had is they had a cell phone where their IPv4 traffic was blocked. But the cell phone was getting a 6-to-4 address, and there was no firewall neither on the phone nor their infrastructure. So you could scan and get port 135, 137, remote task manager, you could turn on the microphone, you could just do all kind of wonderful things to that handset. The vendor made a minor change, but I found out that the minor change was easy to get around, and I requested they fixed it again, so I'm not going to publish that until hopefully they fix it at the end of the year. We also had a BitTorrent application. If you downloaded BitTorrent, it enabled IPv6 by default, usually Teredo. And then we're noticing a trend that a lot of the malware developers are using the Microsoft development tools. So by them using the Microsoft development tools, they automatically have access to AF INET 6. So some of these malware products are actually trying to make IPv6 connections. Also, we have about 120 vulnerabilities specifically in IPv6. And that looks like it's going to start growing. So, you want to find an address on the internet. You want to brute force it. For IPv4, it doesn't take long. Matter of fact, with a special little tool called Unicorn Scan, you can scan the whole internet in about 71 minutes. Pretty cool. Let's compare that against a brute force scan of IPv6. Okay, we have the network and the subnet. We talked about that yesterday. Wow, that's a lot of years. So if anybody has a penetration test or an assessment that you need done, you want to do it brute force, I'm up for this job. This will be a good paying job, okay? And actually, what's even a better paying job is that one, okay? That's like centuries. Okay, that'll take care of people for years. This works. I've been noticing on mailing lists at least a couple times a month, and I'm getting calls at least once a month from customers that are saying, we're seeing somebody trying to brute force our network range. Well, you don't have any exposed public DNS records, and you took all the other precautions I suggested. Where are they in the range? Well, they're now up to AF10. Well, you're way up there. Don't worry about it. They're not going to find you for 40 years. You know, this is good. Okay? So if you protect your outside interfaces and you don't expose DNS information, you choose addresses correctly. You don't use dead beef. That kind of gives things away. It's hard to identify. So from an outside attacker, you have to use DNS to really do a lookup or use some other technique. From inside, we can use ping, FFO2, except if you're running a Microsoft box. Then we use Live6. It actually has specially formed packets, 3 specific packets that force the Microsoft box to give up its address. Yes. We also have fake router for any other device that thinks they're protecting themselves. Again, this is open source tools that you say I'm a fake router and all the systems try to communicate with you. Yes, actually there's also a tool, and I forget the name of it, that allows us to put this tool on a specific server within the network, within your link, and allows you to execute applications on it As an example, one of the little scripts that I have is I document all the devices as they're doing DADs, duplicate address detection. So then I end up with a MAC address and then what address they were assigned. So it makes it real easy because then I end up with a nice little syslog function of who's entered and left that network, which is pretty cool. And that's part of the THC toolkit also. Sorry, I only have so much time. So other fun man-in-the-middle attacks. So what if I set my address to 192.88.99.1? Well, anybody that does 6 to 4 is going to try to communicate with you, right? And by the way, I had a customer one day who was implementing IPv6, and they'd actually used this range. So they called me up frantically. It was pretty cool. Also, any device that has isotap.domain name. By the way, the isotap.domain name doesn't have to be the host. It could be the name that you're using in Bonjour or UPnP or some of the other name services. That's kind of problematic because most organizations don't manage other name services outside of DNS. They allow the application to run those name services. So I would suggest that your IDS, you look for these addresses, you consider blacklisting it. Also, if you see quad A DNS queries, that's definitely a giveaway that you have IPv6 on your network with tunnels. Again, before you've fully implemented IPv6. Enabling IPv6, your tunnels go away. Would you like to see an example of a nice tunnel? Let's see, I'm not sure if you're going to be able to see it up here. I'm going to bring up my second favorite application. Wireshark, can anybody see this? This is a Wireshark trace. And we see a router solicitation, router advertising, see a bunch of TCPs, we see some requests, specifically a quad A request. And then we start seeing all these UDP and we see no more IPv6 traffic, do we? Well, because you can change the port on Teredo, you can simply do this. Nice. Oh, man. This is a drag. Filter. Not filter. The icons are too big. Yeah, that's what I'm trying to find decode. Yeah, decode as. There you go. So if I do decode as, Teredo, apply, we suddenly notice that those UDP packets actually contained a tunnel by default, thank you Microsoft, of IPv6 HTTP traffic. Okay. In this particular case, we changed some of the ports up. By the way, most of the IDSs that you use only use the default port to try to find Teredo. So, bit of a problem. There we go. Oh my God, I went to the wrong spot. You guys are going to have to bear with me for a second. Okay, APT, Advanced Persistent Threats. Those are connections out on the internet that somebody can come in without any controls. Because 6 to 4 allows you to go 2002, C056, 6311, and then the hex encoded IPv4 address. There's ways of detecting devices within your infrastructure that have IPv6 enabled, ports open. So somebody can scan this, which by the way, this is what I use to scan the carrier's cell phone infrastructure, and found all the devices, and then run Nmap against that. I noticed that just recently Verizon's using this, which is the IPv6 gateway and the MAC address of the device. I have a problem with this because I can reduce the address space down to about 24 bits of scannable space, because if I'm just looking for MACs, I know what the approximate, the first address space is. I know about the FFFE. And then scanning the last components, that could be a problem. We also talked about Merido, which pretty much bypassed most NATs. That's kind of problematic. I'm sorry if I'm being really depressing. Let's talk about something really exciting now. IPv6 now allows some very cool new defenses. We have the ability of using IPv6 to control your IPv4 management. Basically, we can use the IPsec once configured correctly to manage multiple systems pretty much out of band. Here's what this provides a big advantage. By having the management at the IPv6 layer, it actually removes a lot of the traffic. We can tag that traffic and say this is management, this is looking for signatures from our IDS, this is logs for sorting. We can actually then have only IPv4 traffic and just look in part of the traffic for attacks and other systems. That's really advantage. We also have the privacy address and local segments. The segments are so large from a local segment, as long as it's a good address, it's going to make it very hard to find. Send CGA, which is implemented in both Cisco and Juniper products and available under Linux, is not available on the Microsoft platforms, unfortunately. Once that's available, that's going to be a big advantage. ULAs, again, large address spaces, kind of think about 1918 address space, RFC 1918 address space on steroids. IPsec. IPsec now has host to host, which is a real advantage. So now I can have one host communicate across the net and actually terminate on another host. But I want to mention this because a lot of times people don't talk about this. Because we can link list IPv6 headers, I can have a host have to authenticate to a gateway, who then has to then authenticate to another gateway, who then has to authenticate to a host. So I can actually create circles of trust within an organization. That's pretty cool. And we can do it either transport or tunnel mode. Once you apply a lot of these features, you can use, I call it SETI, Server Enclave Domain Isolation, which is the ability of creating policy-based firewalls based on IPsec. Therefore, if somebody tries to scan my device and it's not authenticated, what ports do they get? Port 500, and they only get 2 ports. So essentially, from an audit standpoint, it makes it really hard for the auditors. Yes. Also, another new RFC that I'm pretty excited about is Calypso. Calypso allows us to tag packets and tell the interfaces which interfaces those particular packets are allowed to traverse. As an example, maybe I have an engineering, I have a manager, and I have HR, and then I have maybe an internet connection. I can actually tag packets and state, oh, well, these packets should never go to management, or these packets should be dropped at management. So I can actually put specific qualifications within the routing header to control where packets can go. That's another new feature. And also multicast security, which I understand Comcast is looking at to provide video feeds. So some recommendations. Consolidating all of the other issues down. If you're using an ISP, the most secure way to eliminate all additional gateways and have the best trust model is to have an ISP that has a core of IPv6. They support full dual stack. That's a big advantage. They support A and Quad A across V4 and V6 transports. Multicast, some of the providers are not doing global multicast. They're doing enterprise-wide multicast. That's going to be a big advantage. Actually, I think that's the killer application in about 7 years, 5 years to 7 years, once we start moving to V6. MPLS on V6 would be great, but we're still dealing with that. BGP4, which is a good thing to use. Again, other features. For software, make sure that your operating system supports IPv6. Make sure the programming languages support IPv6, and they're using native sockets if possible. Some applications will use proxies. In other words, I know several web applications. They install a proxy so they can talk to IPv6. Well, the proxy has denial of service problems. They have other problems as far as manipulating data, which can be very problematic. User interfaces, you guys talked about parity with IPv4. I actually call the next level is IPv6 empowered, which really leverages so that you know this is a multicast, this is an anycast, you know, this is this class of address, that's that class of address. It's this type of packet with this class of header. Some vendors get pretty confused because there are about 250 RFCs at this point. Some vendors don't fully support even those RFCs. The must may not be a must depending on your vendor. We're going back to stuff that Jeremy mentioned, which is tests, but you know, trust but verify we use in security. In this case, it's test it. Take a look to see if they have some of the advanced security features. Also in the market, we have vendors that have gone to self IPv6 validation. Sometimes the tests aren't fully run. We also have third-party validation, which is really a better solution. 3 different sources for that: the IPv6 Ready, NIST, and DoD JITC. Yes, I have to tip my hat to Jeremy. One of the things you've got to be aware of, some of these, there's 4 components that we should be testing for when we're testing for security. We should be testing for standards and interoperability. We also should be looking at performance and security, because there are some of these products that if we run too many packets through them, all of a sudden we're moving very few packets through them. We could have a 10 gig interface. Ooh, that was pretty cool. A 10 gig interface, but we may only be able to move, you know, 100,000 packets or 10,000 packets. So be aware that's a problem. And also security. Some of the vendors kind of forgot about the security components. So buy beware, go through the testing process. It's a big deal. Let's see, get certified. Here's some places to get more information. Good websites for checking things out. And there we go. And am I even close to time? He's going to yank me off the stage. No question? No time for questions? Okay, any questions? I know I covered a lot in a very short, this, like I said, try to consolidate and also answer some of the questions that other people were asking in the group. And I'll be around all day today and the rest of tomorrow also, if you've got questions. Yes. Yes, also if you look up Joe space Klein space IPv6, you'll get to my ugly website. Yes, my ugly website, because I really care about network protocols, not pretty pictures. I have slides for the last 10 years of my public presentations.
In your first slide about defenses, IPv6 defenses, which of those technologies exist today? Like, you mentioned the SEN, and I haven't seen a real implementation of SEN today.
Both Juniper and Cisco have it on specific binaries or specific versions of their operating systems. There's one version that's available in Linux that works real well, something I tested out. What's really cool about CGA is once you've authenticated to the network, you have 3 tags you can set. You can set, I trust everybody, I trust some people, or I trust nobody. The trust nobody feature is pretty cool, especially under Linux. It allows us to tag and say, unless this address was actually generated a specific way, it allows that device, it allows the device themselves to protect against scanning and other things. It acts more like a NAC for IPv6, which is pretty cool. But again, other implementations, I really haven't seen a Microsoft implementation. I understand there's legal issues there. I've seen Cisco has a real good document on providing some multicast security, and I've seen several white papers and some demo code for multicast security. Haven't seen it implemented yet. It's something I want to do first quarter. By the way, I do all my IPv6 stuff after I do my day job. So this is this is just a passion that I try. But the multicast security I'm going to play with a little bit later. Any other questions? Well, where's the next presenter? He's between you and dinner. Thank you.